First, use pip to install. Use watch run main.py instead of python main.py to run. With just a simple click, you can see the variable values and the call stack being printed out. Let's try another variable. The execution flow is easily displayed. Let's try the fast mode. First, the monitoring information needs to be filled in above. If you are not a monitoring class object, you don't need to fill in this class. Let's fill in a regular variable. We'll copy it, click to enable it, and then run it. We don't need to print it here, I'll run it first. Okay, after running it, you can click here to see the changes of the object we wanted to monitor. Line 21, all line 21, was called twice. Above is its call process. One is called by CCC, one is called by line 27, and one is called by line 31. So it not only shows the variable changes, but also displays its call stack. This file can be saved. You can see that there is no need to add or remove print lines, making the operation more straightforward. You can also click underprint, so when running, this information will be printed directly to the terminal. After running, there will be a history record here. Next time you open it, you can click directly. Let's try it. We'll delete and add one again. It will be more convenient. Now let's look at a more complex situation. This is a relatively complex code. Let's run it without monitoring the parameters. You can see that it ran for 5.2 seconds. Now, when we run the program with monitoring on alpha, we can see the monitoring information, but at the same time, we notice the startup time increased to 32 seconds. At this point, we need to use another feature to reduce the runtime, which is adding a stop line for the trace. Since I've used this before, there is a history record. Suppose we only monitor up to line 52. We can enter 52 here and click enable. Let's run it again. And you can see it returns to 5 seconds. However, if the parameter is assigned at the end of the program, adding a stop line becomes meaningless. In this case, we need to use class object tracking. You can see that I have already written the class here. We change the parameter to a property of the class object, and then change everything here to the class object's property values. It's also fine not to declare global variables here, as global variables can be used directly. Now we will monitor the class object. First, enter the class name, then enter a regular variable and enable it. We choose the trace stop line, select to stop after the class object is created, Choose line 48 and click Enable. You can see that the time taken is almost the same as normal execution. Now let's check if the content has been monitored. We see 2572 and 2573. We successfully used the class object to monitor the variable throughout the process without affecting the runtime speed. By monitoring the variable in this way, we can better understand the program's execution process. Next, let's test the efficiency of this feature when modifying bugs. Now let me explain the bug in my program. Each function is contained within a box, and each box is a flow house. Typically, the house is aligned to the left, but sometimes it jumps to the wrong position. Now let's monitor this class. We'll monitor one of its parameters. We'll select the stop line and set done91 as the stop line, stopping after the class object is created. You can see the time slightly extends because we have recorded some information. Let's see what has been recorded. You can see the class creation process. The monitoring attribute we just filled in is X, and it includes a lot of information. And you can see that we monitored 1671 class object instances. Now let's clean it up and open it again. Only the class instance numbers are left and the information has been deleted. Now I'll start working normally with my program. Now there's a problem. The house is no longer aligned to the left. I want to know where the bug occurred and which line of code seems to have the issue. At this point, I need to check the monitoring information. We can find the location where it appears and its call stack here, allowing us to pinpoint the bug. Some bugs are very difficult to reproduce. Now, we can use the monitoring feature that doesn't affect speed. We can add multiple parameters to the monitoring and then run the program. This way, you can continue working without having to focus specifically on solving the bug. When the bug appears, we can simply look at the records to identify it. Because my code is quite poor, usually fixing such a bug takes 1 or 2 hours, sometimes even 4 or 5 hours. However, after using watch run, the time to fix bugs has generally reduced to a few minutes. By using the class variable name, we can filter the class we want to monitor. If we only want to monitor the class created at line 1090, we can do some special handling with the variable name here. Alternatively, we can change it so it doesn't affect the subsequent program execution. Then, fill in the variable name here. You can enter multiple names. After running, it will only monitor the class instances with the correct variable names. Let's take a look at the effects of other buttons. You can add multiple monitoring objects. Save the current monitoring information. By opening the history information, you can edit and delete some unnecessary history records. This shows the raw information in chronological order. You can print the display information to the terminal here. Monitoring of regular objects is free, while monitoring of class objects requires a purchase. Python contributors can use it for free. Here is the purchase information, and each computer has a different password. Send me the fake password. Here are the usage instructions and precautions. This plugin has greatly improved my programming efficiency, and I encourage everyone to use it.